16,500 feet down on the Pacific abyssal plain, the environment is absolute. There is zero sunlight, and the hydrostatic pressure sits at roughly 500 atmospheres, enough to crush a standard military submarine like a tin can. Down here, physics is entirely unforgiving. Within the crystalline structure of a massive mechanical steel claw, a single microscopic stress fracture begins to form, invisible to the naked eye. That fracture propagates, the high-yield steel shears away, and 3,000 tons of deadweight instantly tear loose, plummeting back into the darkness of the trench. That split-second metallurgical failure at the bottom of the ocean compromised one of the most expensive and highly classified engineering operations of the Cold War. Back on the surface, the solution to this extreme environment took the form of a 618-foot ship operating at 70,000 tons of displacement, the Hughes Glomar Explorer. Publicly, this was billed as a commercial deep-sea mining venture. In reality, it was the multi-billion-dollar centerpiece of Project Azorian, an operation directed by the Central Intelligence Agency. The objective was to reach down 3 miles into the Pacific and secretly steal a sunken, nuclear-armed Soviet ballistic missile submarine known as K-129. Executing this required lifting 3,000 deadweight tons on a 3-mile string of pipe while holding the surface vessel perfectly stationary in rolling ocean swells and hiding the entire operation from Soviet surveillance ships passing nearby. No heavy salvage had ever been attempted at even a fraction of this depth. Satisfying these physical constraints required engineers to invent entirely new classes of maritime technology from scratch. This animated diagram illustrates the primary mechanical hurdle, static friction. A standard ship rises and falls with the ocean swells. If you suspend 3 miles of rigid steel pipe from that moving ship, the sheer bending stress will bend and snap the pipe. To solve this, engineers integrated a massive triple-ring hydraulic gimbal platform. This concentric design absorbed the pitch and roll of the vessel, keeping the central pipe string completely isolated from the wave motion above. Then there was the issue of loading the massive capture vehicle, codenamed Clementine, without alerting spy satellites or Soviet trawlers. The Glomar Explorer was built with a massive internal opening in its hull called a moon pool. The capture vehicle was loaded into a submersible barge, the HMB-1, towed offshore and sunk beneath the Glomar to be hoisted inside, out of sight. Finally, the ship had to remain locked in position over a target miles below, resisting unpredictable open ocean currents. This diagram shows the Honeywell dynamic positioning system. Acoustic transponders were dropped to the seafloor, continuously beaming signal data up to the ship. A central computer processed those waves, automatically firing precision thrusters to lock the vessel exactly on its vertical axis. By linking hydraulic stabilization, an internal submerged bay, and automated acoustic thrust, the Glomar Explorer operated as a highly calibrated macro machine, capable of millimeter accuracy in open water. In the summer of 1974, the operation commenced. The capture vehicle was lowered, section by section, beginning a methodical, days-long descent into the Pacific Trench. However, a KGB mole had leaked the operational tempo of the mission. Soviet intelligence vessels arrived directly on site to closely monitor the Glomar, forcing the crew to execute the extraction in plain sight of their adversaries. Despite the surveillance, the claw successfully grasped the submarine, but as the immense weight was hoisted upward, the microscopic flaw we saw earlier began to manifest, a chemical reaction known as stress corrosion cracking. The engineers had constructed the lifting claws from maraging steel. It possessed incredibly high tensile strength, ideal for heavy loads, but it was highly vulnerable to the cold, crushing, high-pressure marine environment. Under the immense hydrostatic load, the steel fractured. The capture claw gives way, and the massive submarine section plummets back to the ocean floor. By prioritizing raw tensile strength without fully accounting for the chemical resilience needed at depth, the team lost the majority of their target, resulting in a devastating partial failure. The crew managed to hoist the remaining third of the submarine into the moon pool. Inside the wreckage, they recovered the remains of several crew members. 6 Soviet sailors were given a solemn burial at sea. The American crew conducted the ceremony with full military honors, maintaining a profound respect for their Cold War adversaries. Due to severe contamination from the submarine's nuclear material, this ceremony had to be conducted using heavily shielded, lead-lined caskets. The deepest secrets of the mission held firm at sea. The actual breach of security happened months later, thousands of miles away in Los Angeles, during a routine break-in at the Suma Corporation. Burglars stole classified documents from the office, which eventually leaked to the press. The papers exposed eccentric billionaire Howard Hughes as a CIA front, completely blowing the deep-sea mining cover story to the international public. The agency successfully hid a multi-billion-dollar extraction from Soviet intelligence ships directly overhead, only to have the entire operation unraveled by a terrestrial office burglary. The CIA's fabricated cover story triggered a massive, unintended geopolitical reaction. Before the truth was exposed, the international community believed the commercial deep-sea mining operation was real. Developing nations at the United Nations panicked. They looked at the massive ship and genuinely feared that a United States corporate monopoly was about to claim all the invaluable minerals on the seafloor. That fear directly catalyzed the drafting of the UN Clause 3 treaty. To prevent a corporate takeover, the treaty legally declared the ocean floor to be the common heritage of mankind. Meanwhile, the ship itself found a second life. In the late 1990s, the vessel underwent a $180 million conversion, stripping away the spy gear to become a legitimate commercial deep-water drill ship. Reborn for the energy sector, its massive scale allowed it to cut through harsh open ocean waves, operating globally where smaller rigs could not survive. It sailed under the name GSF Explorer, completing a highly successful 18-year commercial career before finally being scrapped in China in 2015, leaving a permanent mark on the offshore engineering industry. A single-purpose machine, custom-built to execute an impossible lie, ended up establishing the very real international treaties and physical engineering frameworks that govern the modern ocean today.